So this is the topic for our today's webinar. We are going to discuss about Docker and Kubernetes, and this is going to be the ultimate beginner's guide. And this is the overall agenda. In this webinar session, we'll be covering we'll start with the introduction, and then we will try to understand difference between physical server, virtual machine, and containers. And also we'll discuss about containerization, what is containerization, and also we'll see hands-on like how to set up Docker machine and how to create a containers and how to work with the commands and all. And also we will see how to
Okay.
like what is Kubernetes and what are the different components, what are the different architectures that are involved here. So we'll see a Kubernetes architecture, and we will also go through the hands-on for Kubernetes, where we will create a Kubernetes cluster, and also we will create a deployment, and we will see how it's going to work. And at the end, we'll have a Q&A session where you can ask me questions and you can uh, clear the queries if you have any. So let's get started with the introduction. So about IT
Okay.
Talent Hub. It's one of the largest independent of IT, and we have overall 1500 plus community members, and we are into market from past 10 years. Uh, and our office is located in Ilford, UK, and which is near to Queen Elizabeth Lane. And we have different teams who are working for training and also for recruitment and also for uh, like uh, building proper networking and all. And these are our clients where we actually work with, and these are our success stories. And recently our students got placed in these companies. And why IT Talent Hub? So to choose IT Talent Hub, the trainers from the IT Talent Hub are over 11 plus years of experience and 10 plus years of experience and 11 plus years of experience. And the curriculums that are designed as per UK job market. And we have strong industry connections, as well as we have teams who are working in the backend for towards training and also for CV analysis, as well as the students placements and all of this. So as a part of this course, we will be having a live projects where you will be working on live projects uh, where there are different types of team members like a testing team, DevOps team, and developer team, and all of them are combined together to create a proper environment that we are working in an organization. And we will be working uh, on a particular project as a DevOps engineer. And other than that, we also have mock interview sessions and real world implementations, best practices, and all of these are discussed in this course. And about the trainer, I am Janjirala Kiran Kumar, and I am working as a DevOps engineer and a subject matter expert in cloud and DevOps. And I have overall 11 plus years of experience, and I have 4x AWS certified and 1x Azure certified, and I also hold academy certifications. These are the list of global certifications that I hold, like DevOps Engineer Professional, Solutions Architect Associate, SysOps, and also Solutions like Cloud Practitioner, Azure Fundamentals. And apart from that, I hold certifications on academy-based certifications. And these are the trainings that I have delivered on, like AWS specific DevOps. And other than that, open source tools like source code management, Git, GitHub, Jenkins, Maven, Terraform, Ansible, Docker, Kubernetes, and Prometheus, Grafana, and all of this. So apart from that, the courses like Linux, Windows, networking, virtualization, and also AWS certified courses like Solutions Architect Associate and Technical Essentials and Cloud Operations and all. So this is about me, and overall I have trained 4,500 plus professionals as of now. And the trainings are like online and offline trainings. And this is the introduction about me, and I'm eager to know about you. If you could come forward and introduce about yourself, like what is your name and background and all of this. Yeah, just a quick introduction is enough.
Yeah, so sure. I am from India. Now I'm in UK. Just completed my master's degree in computing. Before
Okay.
that, I have 6 years of experience in IT as I joined as a desktop engineer, then moved as a system administrator. But it's a VMware admin. We manage our VMware platform along with Azure as well. So I have
Okay.
worked in VMware infrastructure and Azure, like VM management and user identity related stuff.
Okay.
Yeah,
So
Azure AD
more towards
or
Active
normal
Directory.
on-premises AD.
Okay. Okay.
Yeah, more towards Active Directory and user related stuff.
Right. Right.
So access and permissions, MS365 again. So it is also
Okay.
again related to our Exchange Online, SharePoint. So these are
Perfect.
my
Perfect.
6 years working career.
So any exposure or any like learnings on DevOps and cloud? Anyhow, you worked on Azure. Okay, that's okay. But about DevOps.
Azure, yes, Azure, virtual mission manager, resource management, and all we have all already in place to data center, like virtual machines were there, so we were managing, checking the like performance, these kind of incidents we work there, and
Okay.
yeah, the
Right. Right. Got it. So hope you haven't worked on DevOps tools or DevOps role, right? As of now, no. So can we say
no,
like
at the moment no, but for my masters, I have just developed a application in Python and using Docker and Kubernetes services from AWS, just hosted on it. That's it. Like that's for my dissertation. But I didn't had proper
okay?
experience on that.
Okay, got it. Got it. So yeah, that's fine. Thank you for your introduction, Rohini. Yeah. So let's get started with the actual concept what we are going to discuss about. So first, we'll try to understand, as you have already worked on this Docker and Kubernetes, I think you have some idea about this difference between physical server, virtual machine, and containers, right? Now let me quickly show you like what actually it is. Like, what is a physical server, as per your understanding? Like, why we generally use this physical server? Any purpose? Like,
So physical server, you can say that we can install a server OS on it and use as a particular service, like either as a web server or DNS server, DHCP server. Like you can configure that to work for that particular service.
perfect,
So
perfect.
physical means
Yeah.
what like you should have a physical device for that, and
Mhm.
over it you can install an operating system. Yeah.
Perfect. Anyhow, you worked on these physical servers and virtual servers as well, right? You have good idea about this. So using this
Yes.
physical server, we can
Mhm.
even generally deploy the applications like you can deploy app 1, app 2, and MySQL type of databases, and all of this you can deploy on a physical server. But what are the demerits that we come across if we are using a physical server? Any idea like what are the demerits?
You should have a space, more space, more power should be there.
Okay.
Like, yeah,
More space, power, and what about auto scaling? Scaling?
how to say, yeah, another thing, like, yeah.
Scaling is also one of the demerit we can say because there are certain limits. So beyond that limits, we cannot scale it, right, in a physical
Mm-hmm.
server. And apart from
Scaling.
that, what about
Mhm.
high availability? Can we achieve high availability in a
High
single server?
availability, right? Yes, yes.
Of course. So using a single
No.
server, we cannot achieve high availability because the meaning of high
Mhm.
availability is like availability in more than one particular server or one particular location. So when it is available in a more than one server or more than one location, then we call it as a highly available. Or sometimes we even maintain a minimum of 3 copies. So that's what we call it as a high availability. And as you mentioned, like space, power, scaling, and high availability, these are the demerits of a physical server. So we come across like
Physical
shortage
server.
of this, right? And apart from that, let's say
Okay.
there is a person or a hacker we can say who wants to hack this server. Let's say he got the access to the operating system or any of the underlying hardware and all. So is it a safe practice? Like, can we go through this
Mm-hmm.
kind of approach where we have installed multiple applications? Is it a good practice? like hacker got the access to the physical server or
No.
operating system. Of course, this is also one of the security issue, right? When we are hosting multiple applications on a
Security
single
issue, yeah.
server, yeah, this is going to be a problem again.
Mm-hmm.
So what are the pros here? We can have full control. It is predictable. It is going to give you predictable performance, of course, but scaling and high availability as well as the security is one of the concern in physical server. Now later on, we actually moved from physical server to the virtual machines, where we can use the same physical server, but we can split that physical hardware into multiple virtual category, like multiple virtual components. So in the same image, we can see like this is one server which has a CPU, RAM, and input output disk and all. So instead of deploying all the applications into a server, here what we are doing, simply we are using one software or one uh, like we are installing hypervisor. So this hypervisor will help us to create multiple virtual machines. Instead of a single physical server, we can split this into multiple virtual machines by using this hypervisors, where we can create a separate isolated machines. This you have already used in Azure and all of the platforms wherever we come across the virtual machines, right? So these are isolated and we can
Mm.
use it
Yes.
for a specific purpose. Let's say I want to deploy one application in one virtual machine, another application in another virtual machine, and MySQL database in another. So we can do it like this. Now, what are the advantages and disadvantages between virtual like physical server and virtual machine? Physical
Uh,
versus VM, any identities?
Physical server, you should have all the yeah, connectivities in physical, like power, CPU, and RAM, everything you have to be there. But in virtual machine, the same thing you can distribute and give it to each. So everything on virtual, like virtual power, virtual network will be there, virtual RAM, everything virtually. Uh,
Oh,
but
perfect.
taking the same resources. Yeah.
Yes. So here what happens is like we are not specifically allocating the resources for a particular app. One app can use more, another app can use less,
Mm-hmm.
right? So resource consumption is
And
also different. So here in this virtual machine, what we can do is we can allocate the resources. Let's say I want to allocate a CPU, I want to allocate RAM, I want to allocate disk space, and all of these can be allocated by ourselves. Like manually, we can do this. So
yeah.
here we also have an option of choosing operating system. So you can either go with a Linux operating system, you can go with Windows, or you can go with any operating
Mhm.
system that are available.
Windows.
Yeah. So these are the advantages of virtual machines. Okay. Now how virtual
Mm.
machine is beneficial from physical server? How it is beneficial? One thing is isolation, right? So all
Mhm.
these like app 1, app 2, app 3
Yeah.
are isolated from each other and they don't have any connectivity, right? They are separated. And all of the
Mhm.
resources from virtual machine are utilized by physical server, of course. Now second thing is like uh,
Mhm.
as discussed, like there is a hacker who wants to hack any of the application. Let's say one virtual machine is under his control. Now can we say that other virtual machines are also compromised? No, because one virtual machine is
No, no.
it both all are isolated, so they are different. So we can
Mhm.
deploy different applications
Mm.
onto different virtual machines and we can use it. So this is also security is also one of the benefit. So isolation and security, and other than this,
Mm.
space and power. So as you mentioned space here, we can allocate the space also. For one virtual machine we can allocate, for example, 50 GB, another virtual machine we can allocate 25 GB and 20 GB. Like this we can do it. We can uh, like calculate the space and we can allocate for a different virtual machine. But whereas in physical server, so we cannot do that
Mm.
directly. So this is one of the advantage. And other
Mm.
than that, like a scaling and high availability. So if I talk about scaling, it is not
Mm.
auto scaling, but we can obviously increase the capacity manually. We can say vertical scaling is possible.
Mm.
vertical scaling is possible there. And
Mm.
other than that, we can say power
Uh,
consumption. Yeah. Anything to add?
yeah. No, no, no.
Right, right. So vertical scaling is also possible, and we can say overall it is secured, it is isolated, and also space can be allocated, and we can do the vertical scaling. We can increase manually and decrease it. Right. So these are the advantages over physical server. Right. And in this picture, we can
Uh,
see there is a hardware, and on top of hardware, we have installed host operating system, and on top of this we have installed
mm,
hypervisor. This hypervisor will help us in virtually splitting the resources. So for one virtual machine we can allocate some resource, and for other virtual machine we can allocate a different capacity of resources. So this is the possibility with a
mm.
hypervisor here. Now we will compare the difference between virtual machine and containers. So like what do you think, like what is the difference between virtual machine and container?
Container may be a group of virtual machine or the storage.
Group of virtual machines, of course they are also a group of container instances, we can say. Okay,
Mm-hmm.
and so yeah, if I talk about containers, so same technology is
Mm-hmm.
same, but the way or the container runtime that we are using is different. So in case of virtual machine we were using hypervisor,
Okay.
which helps us in creating a isolated virtual machines. But in case of containers, what we'll do is we will
Mm.
replace hypervisor with a container engine. So container engine is also similar technology, virtualization technology only, but the major difference between a virtual machine and container is, like, if you have any idea you can tell me.
No.
No, okay, no problem.
Maybe different storage space is available for container application or
Different storage spaces. Okay, so we can look at this differences. Like this is a physical server, which is a bare metal server where
mm-hmm.
we are only using host operating system, right? So whatever operating system that we are installing directly
Okay.
on
Huh.
top of hardware is called as a host operating system. And we switched from this to this because we want to create multiple isolated virtual machines, and we want to make all the applications separate. So that's the reason on top of hyper host operating system we installed hypervisor, and we are able to create a multiple virtual machines. This is possible. Now in this every virtual machine we are installing again operating system. So this is going to be called as a guest operating system, right? Host operating system and guest operating system.
Mm.
Now, can you tell me, like, approximately what is the size of our operating system generally? Let's take Windows, 4 GB, 5 GB, 6 GB. Let's say approximately 5 to 10
Yeah,
GB,
60, 5 to 10 GB. Yeah.
5 to 10 GB. And on top of it, if we are installing any other software, then again the space is going to be increased, like
Mm-hmm.
whatever the occupied space is there, that is going to be increased, obviously. But
Yeah.
if we talk about the
Yeah.
only operating system, we can say approximately 5 to 10 GB of space is going to be occupied. And if we are installing, like if we are
Mm.
creating multiple virtual machines, this is guest operating system, this is guest operating system. Again, if I create 5 virtual machines, I have to install 5 operating systems for every
Yeah.
machine and host operating system. Now, what is happening here? These are consuming
Yeah.
lot of space. These are consuming lot of space here,
Mm.
which results in slow performance, right? Which results in slow performance. We can
Yeah.
say boot time. Let's say a virtual machine needs to be restarted, or due to some XYZ reason, we have to remove that instance virtual machine and we have to recreate it. Obviously, that is going to take more time, right? Boot time, or we can say recreation of a virtual
Mm.
machine, is going to take more time. So this is one of the like again demerit in virtualization. where we could not be able to recreate or
Okay.
restart the machines. Later on, what we have done is like we have gone through
Hmm.
another technology called containerization. So in this containerization, the
Hmm.
possibility is like we have replaced a hypervisor with a container engine. So using this container engine, what we have done is whatever the containers that we are deploying or creating here, this also has OS, operating system. But generally, every operating system will consist of like application programs plus kernel, right? So every application operating system consists of
Hmm.
uh, different types of basic applications. Let's say if I install Windows operating system on my machine, we can say it is included with Paint, it is included with a Notepad, it is included with the Internet Explorer, right? These are the important and basic applications
Hmm.
that are also included with operating system. Other than that, we also have a kernel. Now, in case of virtualization, every virtual machine have app and kernel. This is the reason it is increasing the size of operating system. So when we include apps and kernel both, so
Hmm.
this is going to occupy more space. And as a result, it is occupying more space and the performance is also less when compared to that of containers. Now in containers, what we have done is like using this container engine, we are able to create containers. Of course, we are using operating system, but this OS image is going to be the base image. That means, let's say in virtual
Okay.
machines, if the operating system size is like 5 GB, in case of containers operating system, like base image is going to be 50 MB, or we can say 100 MB, like this in MBs only. But in case of virtual machines, it can vary, depends on the type of operating system that we are using. So when compared to virtual machines and containerization, containers, so which one is more like efficient, good in performance? Of course,
Contain.
containers,
I
because
think so. It's contain.
yeah, of course containers, because it is occupying very less space. Because of this very less space, it is booting very fast, right? Whenever we want to boot it or restart
Hmm.
it or recreate it, it's taking very less time when compared to that of virtual machines. So this is one of the biggest advantage of containers when compared to that of a physical server and a virtual machine. So because of that reason, as we are using only base image of operating system, this is helping us in quickly recreating, quickly restarting, and also creating multiple replicas of same container. So this is the advantage that we
Hmm.
are taking out of these three types of technologies. So that's the reason nowadays we are preferring containers, and everywhere we are using containers to deploy our applications, multiple microservices. Everything is deployed on a containerized platform only. Right. So this is the difference between physical
Hmm.
server, virtual machine, and a container. Right. Hope this is clear
So
to
in
you.
container, it will be only one base mission, base image, right? Or individual container have individual base image.
Of course, we can have individual containers can have individual base images. This container can have Alpine image, this container can have Nginx, this container can have HTTPD. So different images are there. So we can use any image for any container. So it's not like we have to use only one container image. But generally what happens is like when we are deploying any application.
Okay, is it like can we use Windows, Linux flavors here?
Yeah, of course, we can also use that here. But most preferable one is
Okay.
like uh, Linux, because most of the production environments we generally go with the Linux operating system only. But in our Docker images also we have only this kind of images like Alpine image, or we can say HTTPD or Nginx and all of these images. So base images. So other than that, if it requires any of the uh, kernel, so or the resources that are going to be used from the host operating system resources, right?
Okay.
So mostly we prefer Linux only. So this is the difference between a bare metal virtualization and also containerization. And what are actually containers here? So containers are like it's a kind of a box in which we add all of the required things, right? So we can arrange all of this into a single box and we can call it as a single unit. So what different types of things that we are including here? We include code, we include configuration, and also we include dependencies as well as the container runtime engine. So we combine all of these into a single unit and put it in a single container. So this is how a container is going to be created. So by including all of this, we generally create one image. So same like virtual machine. So to create a virtual machine also, we need one image, right? We need an image generally for our physical servers or like we generally use ISO images. Okay. But in case of virtual machines like AWS, we generally use AMIs, Amazon Machine Image, which is used to create a virtual machine. So
Machine
again, what?
image.
Yes, yes. So these images are like we can say it's a template. So we can say it's a predefined template in which everything is mentioned. Using that particular image, we can create a virtual machine. So in this image, we can mention type of operating system and storage type and also virtualization type as well as the architecture and all of this. In the same way, to create a virtual machine, we are using virtual image, that is Amazon machine image in case of AWS. And here also to create a container, we use multiple types of images, right? So this image we call it as a Docker image. So to create a container, we generally use images and generally we use Docker containers. So we call it as a Docker image and this image can be stored in a repository. Right. Now, when we are creating containers, how these containers are helpful or beneficial to us? We can say containers are lightweight when compared to virtual machine. Do you agree? When compared to virtual machine,
Yeah.
containers are lightweight because in virtual
Yeah. The
machines we
size
are
will be.
size is very less and booting speed and it is more efficient than when compared to that of virtual machine. And it is also portable and also we can say efficient way to package and run our applications. So we include all of this like code, configuration, dependencies, and runtime. And including all of this, we create one image and we can quickly create hundreds of containers, thousands of containers in a very quickly, right? Using this particular Docker image. Now, how these are beneficial to us? Like it is portable. We can run the applications anywhere, either local, either cloud or on-premise as well. And also it is very efficient. It is going to use very fewer resources, right? So when we talk about virtual machine, due to the extra space that it is taking, like operating systems are consuming more space to operate it, it also require more resource capacity. But in case of containers, as the entire operating system size is like it's a base image and it is in MBs only, so it is not going to consume that much of resources. So we can even save the resources and we can allocate the same resources to different machines, right? And when we talk about scalability, of course, these are highly scalable, we can say, because one container is going to use only the capacity that it requires. Other than that, it's not going to consume and it can easily scale because of the less size and based on the demanding increase. And also faster deployments, like we can do the application deployments very fastly because uh, containers will spin up very fast because of its nature, like as these are light in weight, so we can deploy it very fast. And isolation, of course, same like a virtual machine, we can also have isolation in containers, right? So if I talk about the
Yeah.
containerization work, like how this is going to actually work. So container packages the application and its dependencies into a single unit, right? So whatever the dependencies that we have seen here, it is going to consider it into a single unit and it runs a container. It runs on a container runtime. Like we, instead of hypervisor, we'll be installing Docker or container D. These are the container engines that we can use. Either you can go with container Docker or containerd. And other than that, containers share the host kernel. Just now we discussed that in case of virtual machines, they have own operating system plus kernel. So every virtual machine have operating system plus kernel, sorry, applications plus kernel and all. So OS includes kernel. So this is going to become heavy. But when we talk about the container, so when I talk about container doesn't have the kernel here. So container doesn't have kernel and it is going to use it from the host machine. So this is how it is going to be very light and making it more efficient than VMs, of course. So containers can be orchestrated, which can be easily managed as these are light in weight, and we can say like it can quickly spin up, and which we can quickly recreate, which we can quickly restart. Because of this nature, we can use some kind of orchestration platforms like Kubernetes, Docker Swarm, and OpenShift, and many platforms are there. Like we can use this kind of orchestration tools to orchestrate and manage hundreds of containers, right? We can scale easily with the help of this kind of Kubernetes tools. Now, if we compare the difference between the virtual machine and a container, containers are light in weight and virtual machines are heavy, and we can start or we can create the machine containers in seconds. And for virtual machines, it's going to take in minutes, like 1 minute, 2 minutes, 3 minutes, depends. And containers are going to share the host kernel, but whereas virtual machine has its own kernel within the operating system, right? This is the biggest difference. Like we can say kernel is used from the host in case of containers, but in case of virtual machines, every virtual machine has its own kernel. And resource efficiency, we can save lot of resources here, but here we cannot save more resources because it's going to consume a lot of resources. Again, this is the very important pointer to note. And scalability, of course, this is very easy to scale and it is not that easy to scale. This is the difference between a virtual machine and a container. So that's the reason containers have become very popular, and everywhere we are using container based platforms only. Now, these are the real world use cases where we actually use the containers. So developers generally run the same containerized application either locally or in production, in clouds or anywhere. And also no dependency conflicts, right? So earlier we used to depend on like in if the developers and the deployment team are using different operating systems, okay, there could be a conflict of dependencies. Like let's say developers are using we can say both are Linux only, but these people are using like Red Hat operating system, and ops team, they are using Linux only, but let us say they are using Ubuntu. Now what happens is here the dependencies, like they are using yum modules, right? They are using yum package manager to download the dependencies. But in case of ops, they are using Ubuntu, they need apt here. Okay. Now what is the difference between these two? Like when dev team is trying to execute or check the application, it is working fine. But when they pass it to the ops team, as they are using a different package manager, now this is going to again throw a error because these two are not matching. The operating systems are not matching. So because of these reasons, always there used to be a clash between two different teams, and it was delayed, right? So this is the problem in using different virtual machines with different package managers. And later on, to solve this kind of issue, uh, Docker came into picture where we can create a Docker images. So once we create the Docker image, we can share the same Docker image to the ops team so that they can deploy it using a same Docker image, right? And apart from that, like faster updates and rollbacks, so we can quickly roll back to the previous version. This is also possible with this Docker containers. It's when compared to that of traditional deployments, rollbacks are very quick, very fast. And other benefits, like we can use this in microservice architectures where we can create hundreds of containers and we can deploy multiple services into multiple uh, containers and all. And we can also integrate with CI/CD, Docker, Kubernetes, and can be integrated with a CI/CD as a part of DevOps best practices. We generally create a CI/CD pipeline to automate the entire process. So as a part of that, we can even integrate Docker and Kubernetes with CI/CD pipelines for automated builds, tests, and deployments. And also we can use this Docker and Kubernetes in either hybrid, or we can also go with a multi-cloud deployments or complete cloud-based, we can say cloud native type of uh, applications or workloads. So these are the real world use cases. And these are the popular containerization tools like Docker. We also have Podman. We also have Containerd. We also have lightweight Linux containers. So we can use any of this, but most popular one is Docker. So whenever we go for any job, definitely they are going to ask for Docker and Kubernetes, right? So in case of any DevOps engineer role,
Yes.
we can search in the Google and they're going to ask Docker and Kubernetes, right? Let's quickly go through the Google and DevOps jobs in UK. You can simply search for this and we have many openings here and we can click on any of this and see what kind of skill set they are looking for. We can see this in the skills and experience required. So as a DevOps engineer, we must be
Mm.
like having all of these skills like experience working with agile concepts, Scrum or DevOps related automation concepts. And they are also looking for any of the cloud platform like either AWS or Azure. And also they are looking for infrastructure as a code, either Terraform, Puppet or Chef, Ansible. And other than that, we also must be aware like ECS, AKS and Kubernetes, Helm and Docker. So everywhere in most of the job requirements, they are going to ask for Kubernetes and Docker. This is very, very important nowadays because every application is going to be deployed in a Kubernetes cluster. So knowledge of this and certifications of this Kubernetes and Docker is going to help us a lot. So when you mention this Docker and Kubernetes skills in your resume, even the chances are more for shortlisting and getting jobs. Other than that, we also have other DevOps tools, of course, but like some jobs, they actually look for production environments where they need only Kubernetes and Docker. If you are well versed with this kind of technologies, like they can quickly take you into the role. Other than that, we can also see like CI/CD pipeline servers, like CI servers. We can say Jenkins is there, and also we have Bamboo CI and Conco CI and many other tools. So whenever you find this skills and experience required, definitely it includes Docker and Kubernetes. It's mandatory in 2025,
Mm.
right? Yeah. So this is about the skill set for a DevOps engineer. Any questions as of now, Rohini?
Since I have not have experience in this DevOps, like it is completely different from here. It's mentioned cloud technologies as Azure, right? So as a DevOps engineer, we won't be working in the virtual machine level, right? So we'll be completely on different like two what you call features in Azure portal. Or are we, like I
So
said, like DevOps engineer, like from everything, like virtual machines? As an infrastructure engineer, we were working on virtual machine. So when container comes in,
mhm.
so how it is, the day-to-day activities,
Of
how
course
it will be
we can install
for
Docker
DevOps.
on a virtual machine. Of course, we can install Docker on virtual machine
Mm.
and we can create containers. See, a server is just a base. Server is just, it's going to be a base. On top of it, we are installing Docker.
Okay.
And on top of it, we are creating this,
Okay.
right? So we install Docker engine, and on top of Docker engine,
So
we are creating.
Docker is an application, right? Like we can install.
It's a kind of Docker engine is a kind of tool or software, we can say, same like hypervisor. So when you, as the infrastructure engineer, you have worked
Okay.
on hypervisors, right? So we are just replacing hypervisor with
Hypervisor,
Docker.
yeah.
We are just replacing hypervisor
Docker.
with Docker.
Okay.
Okay. So if you are installing hypervisor,
So how about the end user? Like, yeah.
yeah, please go ahead, please go ahead.
No, no, like if I'm saying if by using Docker, we will be implementing a like platform where we can install application or something. So for the end user, like we'll be just giving access as a SaaS or something. If you are saying they'll be only
Of
having
course,
the username and password to just log in there, but not. I am
right.
just confusing here. Okay, like as an like engineer who works on DevOps, they'll be managing. Definitely, there is no operating system for each container, right?
So there will be a operating system, but it is the base image. I'm talking about like base image, which doesn't include
Hmm.
kernel. So the base image size is going to be very, very less when compared
Okay.
to that of virtual machine size. So this is how it's making it very light in
Okay.
nature and very quick to spin up, very quick
Mhm.
to recreate, very quick to reboot. And here there are many advantages when we are talking about Docker. Docker is very, very powerful.
Okay.
So I'll even show some practical
Okay.
here. We have a hands-on to like see how can we create a Docker containers, how to install and everything. So whatever the questions that you're asking, yeah, I can clear that questions in the coming demo. All right. So we have a demo for that.
Okay.
All right. So this is about the containerization, and we also must be knowing like what is
Mhm.
Docker and what is the purpose of Docker, how the Docker architecture is going to look like. So Docker, in DevOps, we have many tools like starting from Git, GitHub, Jenkins, Maven, Ansible, Terraform, Docker, Kubernetes, Prometheus, Grafana, ELK stack, and many tools are there. So from that, Docker is one such platform
Mhm.
or one such tool which will help us in creating multiple containers, and it is a free and open source tool which
Mhm.
every company can use it, and it can be easily installed, and on top of it we can create a containers and we can run it. So it is very consistent, which gives a very good results and which can show very good improvements in the performance when compared to that of virtual machines. These are lightweight, portable, isolation and scalability and faster deployments. And this is the Docker architecture where we can see and understand like how a Docker is going to actually work. So in this Docker, we can say this is the Docker.
Mhm.
mm, like this is a Docker host. So whatever the virtual machine we are talking about, like in Azure, you worked on VMs, right? Virtual machines, Azure VMs. So on top of
Mhm.
Azure VM, we actually install a Docker. Okay. So we actually install Docker onto it.
Okay.
And inside that machine, inside that host machine, it includes client. Okay. So which is going to take the inputs from the user. So let's say me or you want to execute some commands in Docker. Let's say if I want to build a Docker image, I'll execute a Docker build, or if I want to pull a image, I'll be using a pull here. And if I want to run any container, will be running the containers using. So as a user, we'll pass some commands, Docker build, Docker pull, Docker run, and all of these commands. So who is going to listen? Client, Docker client is going to listen all these commands. And this Docker client is going to give an input
Mhm.
to the Docker daemon. So Docker daemon is going to listen from Docker client. So whatever the command, like let's say Docker pull. Pull is a command used to pull any of the image. Okay. Now let's say we are executing Docker run command. So Docker, when we run Docker run command, it is going to check for the images. As we are talking about the Docker images, so we also have a Docker repository, local repository. So when we run Docker run, it is going to check in the local host first. In host, if the images are available, it's going to use the same image for creating containers. Let's say this image is not available. Now what it is going to do? It's going to quickly go through the registry, which is a public Docker registry. So that's nothing but Docker Hub. So hope you heard about Docker Hub, right?
Hmm.
So Docker Hub is a web hosted platform
Yeah, I
where
have.
we generally save the images, where we generally save the Docker images. So whenever you run a Docker run, so first it will check the image locally. If the image is not available, then it's going to pull the image from the repository. So public repositories like Docker Hub. Now it is easy to pull, easy to use, and it is free to use. Docker public images are free to use, and it's going to create the containers. So this is how a Docker architecture works. As a user, let's say I have given a command like docker run. So it will check the Docker image locally. If it is available, it is going to create the container quickly. If the image is not available, uh, it's going to pull from the Docker Hub. Okay, so this is how it's going to
Docker Hub.
actually work. All right. Now, yeah, this is how a Docker works as a developer. So what we generally do is developer or DevOps engineer, anyone. So we will generally write a Docker file to create a Docker containers. Now, when we write a Docker file, so we will give some instructions that I want to create a container based on this, right? So I want to pull the code. I want to expose this port. Okay, all of these instructions we'll write, and we will first build the Docker image. So based on the Docker image, it is going to be pushed to the Docker Hub, which is a central repository in a web hosted platform. And from Docker Hub, we can simply pull the image. So once we store the image in the Docker Hub, we can pull the image and we can create any number of containers. So you can use that image for staging environments, or we can use that image for a testing environment. So once we create the image, then it is very easy for us to quickly pull and create the containers. So this is how actually a Docker works, right? Hope this is clear to you, Rohini. Yeah. So we'll quickly see the demo for this. Any questions, Rohini? Any other questions or before going for a demo?
No, now it's fine.
Right. Now I am just using my AWS account. Okay. I need one virtual machine first. So I'll launch one virtual machine, and on top of virtual machine, I'll be installing Docker, and I'll try to execute the commands and create the containers there. So let's go to EC2 service. EC2 is a virtual machine in the cloud. And instances, quickly launch the machine, click on launch machine. And this is the guide I'm using. Okay. So I already have a guide. Okay. So quickly I'm using this guide to see the demo here. So I'll be using the Docker instance name as Docker server. Okay. I'll be going with Ubuntu as the image AMI. In the image, you can see it includes the image version and also AMI ID and 64-bit architecture, and also virtualization type, and also root device type like storage and all. And apart from that, I'm just going with a T2.micro instance here, which is one which is going to provide us 1 vCPU and 1 GB of RAM here. And we need a key pair. Hope you are aware of key pair, like why we use key pair here. Okay. So next is going to be the security group, which is going to allow us to connect through SSH. I have already created a SSH, like I have already created a security group. I'm just using that, and I'm providing a 10 GB for my virtual machine. I'm just clicking on launch machine. Once it is launched, I need either PuTTY, or we can go with a mobile extrem, or even we can use PowerShell. So I'm just going with a mobile extrem here. SSH, and I'll come back here to the instances and select the machine that is launched here. And then I want a public IP here. I'll just paste public IP, and I'm using Ubuntu as the username, and I'll go to private key, click on this and choose the private key. I'll go to downloads. I have that key pair here and select it. Now with this, I'm able to connect to the virtual machine. So I'm into the virtual machine now. So quickly I've launched the machine and I'm into this particular virtual machine using a public IP and a key file, key pair. I'm able to SSH into this. Right. Apart from this, I'm going to execute all these commands. Okay. So like I'm first installing, first I'll update the server, then I'll install Docker, then I'll check the Docker version and I'll like start the Docker and enable Docker. So using these commands, we can quickly install Docker and we can work with the Docker. Okay. So once I install this, update and install Docker, then I'll be running a simple Docker container using these commands like Docker run and hello world. I'm using a simple hello world image from where we can easily create a container. So this is the Docker Hub, which I have already logged into this. So we can simply go to Google and we can search for Docker Hub. And from here, we can search for HTTPD image or any type of image that you can search for. So once I click on this, you can see this is the image which is already created and available here. And this is the officially authorized image, like Docker is recognized this, right? And we can easily use this. So Docker pull HTTPD, this is the command to pull the image to the local Docker platform. So like this, we can store our images in the Docker Hub and we can use it. So similarly, I'm using Hello World. So simple Hello World image, I'm going to use it to create a container, right? Now I'm just going to install Docker. First, I'll update this sudo apt update and upgrade. So once I do this, I can quickly install Docker.
Okay.
So you mostly used Azure VMs, I think, right, Rohini?
Yes.
Have you worked on AWS? AWS EC2s?
AWS, yes, I have not in the organization, but I created this instance S3, everything on my master's degree. I was having
Okay,
our like credential from university,
okay,
and we were doing demos there.
perfect. Okay. So I think you already are aware of AWS, right? So you have used.
Yes, yes.
Okay.
So Docker is from any organization or Docker itself a company? Like, is it from Azure or AWS, Amazon, or who's
No,
the
it is
owner for
separate.
them?
It is open source. It is open source again.
Oh,
So we have many open source
oh,
platforms.
oh.
So like Docker, Kubernetes, and all of this.
And like, okay, now another question. And now, see, on-premises devices, now we migrate to cloud, right?
Okay.
Like now it is happening, Azure. So
Mhm.
here, if Docker is a new idea, we can say, like containerization is a new idea or something.
No,
Later
it's
VM
not a
it
new
came, right?
idea. No, after
Okay.
VM only Docker came, no? Like containers came into
Oh,
picture. So just now we have seen, no, like from
okay.
physical server,
So
we
if
switched to
if an organization wants to move to cloud, so they can opt this Docker.
yes, on top of virtual machines, same like what I'm doing here. So we can even do in this way, or else if we
Okay.
want to use their services, we also have ECS, Elastic Container Orchestration Tool. And if you want to use Kubernetes on AWS, we have like EKS, Elastic Kubernetes services and all of this. So you can even
Hmm.
leverage this kind of services to uh, bring our workloads from on-premise to cloud. We also have all these services.
Oh, okay.
So using these services, we can bring our workloads from on-premise to cloud. Right. Just now I installed the Docker and I'm checking the Docker version here. So it says this is the Docker version and we have installed on top of it and we'll be just starting the Docker and also we are enabling Docker. And after that, we have to add the current user. So if I execute Docker images command, now it says that permission denied. So directly I cannot use this Docker. So for that, I have to use the current user, like whatever the Ubuntu user is there. So we have to add this particular user to the Docker group so that we can use this particular user. So again, I'll be executing this Docker images command, Docker images. So images. Now this is going to show the list of images that are available. So currently there is no image. We haven't pulled any image, so it is not displaying any image here. And these are the headings. So we can just pull one image. Either you can run docker pull hello world, it is going to pull the image, or directly I'll run docker run. So with this docker run command, which is going to check the image locally. So whatever the image that we are talking about, so this image, if it is available locally, it's going to directly create the container here only. If the image is not available in the local repository, it's going to pull it from the Docker Hub. So now let's check that. Now it says that image is not available, and hello from Docker. Yeah. So we can see here, unable to find the image. First, it is checking in the local machine. It is checking locally, and it confirmed that it is not available in the local repository, and it's going to pull it from the Docker Hub here, right? So Docker images, you can see we have just pulled Docker hello world image, which is from the public repository. Now we executed the command called docker run. So run is a command which is used to create a container. Okay, run is a command which is used to create a container. So to create a container, it checks locally for the image. If it is not available directly, it's going to. So with this, we can also check that Docker containers are created. Docker ps-a. So this is the command. Docker ps-a is a command which is used to check uh, the Docker containers which are created and available in this machine. And I can also use Docker ps. It is going to show only active containers. Okay, Docker ps is going to show only active containers. And if you want to see either active or non-active both, we will just add a flag here -a, which is going to show the containers that are created and exited. We can see here this container got quickly created and exited because there is no task that is running onto this on top of this container. So we can use a sleep command to make it active, right? And by this we have created one container. So docker ps. So with this we can see whether the containers are available and active. So with this -a we can check whether the containers are created. Now container is created. This is the container ID, but it is not running now, right? So like this, we can create a container and we can use it. Okay. So if I want to create one more container like a Docker run, instead of hello world, we can simply say any image name, Alpine, or you can see here, it is checking locally and there is no image available locally. So it is pulling from the public repositories and it pulled the image. Now, when I used run command, now it should show Docker ps-a. Now you can see there are two containers. So this is one container with Alpine image and this is another container using a hello world image. So if I say instead of Docker run, so we can use nginx again. So it's going to again check locally and it is not available. So it is extracting and pulling from the remote repository, right? So this is how we generally create containers manually using a Docker image, right? Yes. So this is how we work with Docker. Hope this is clear to you. Any questions on this?
Okay. No.
Right. Now let's quickly go through the Kubernetes. Are you aware of any container orchestration platform? So why we go with
No.
container orchestration? What's the purpose if you are aware of?
Maybe along with the dependencies you can install on a multi
Multi-node,
environment or something, like if you
multi-node, multi-container.
yeah.
So as of now in Docker, what we have done, we have created one EC2 instance, right? which is a virtual machine in AWS cloud.
Hmm.
Okay. On top of it,
Hmm.
I have installed Docker,
Hmm.
installed, and I have created a container. Just now we have created containers, right?
Content. Yeah. Yeah.
So this is limited to a single machine. Okay, this is limited to a single machine, that is
Hmm.
EC2 instance. Now let's say I want to
Hmm.
deploy an application which should be highly available. Okay, and it should be
Hmm.
highly scalable, and it should be automated,
Hmm.
right? So whatever the containers that we have created manually now. So just now we have created manually, but one container, two containers we can create manually and see that. But what if we want to deploy an application in such a way that it's completely production environment where there are like thousands of containers? Okay, so thousands of containers, we can't manually
Hmm.
manage that. We can't easily manage that thousands of containers. So in such case, we need some solution which can automatically create containers, which can automatically recreate containers when the container fails, right? Which should help us in managing the scaling, high availability, and all of this. So
Hmm.
in case of all these conditions like automatic auto management, we can say, like recreation of containers, we can
Hmm.
say scaling, this should be automatic, and we also need high availability. These are very, very important, right? If we are hosting an application in any of the platform, it should be highly available first thing. There should not be any downtime, and it should be highly secured,
Hmm.
scalable. Recreation can be easily like failures. So generally failures happen, but in that case also it should automatically identify and recreate it. And everything has to be, entire cluster has to be auto managed.
Hmm.
So for this, we come across the platform called orchestration tool. Like we can use orchestration tool which can manage hundreds of thousands of containers,
Hmm.
and it can take care of. So Kubernetes is one such orchestration tool which helps us in automating all of this. So we don't need to bother about like a creation of containers and recreation of containers, installing some updates, right? Scaling, and also high
Hmm.
availability. We don't bother about that. So we use this kind of platforms. Now again, what is Kubernetes here? We also called
Yeah.
Kubernetes as K8s because the first letter and last letter. So between these, there are
Hmm.
8 characters. So that's the reason, sorry, between
Okay.
here only. Okay. So K8S.
Hmm.
So here there are 8 characters
Yes.
between K and S. So we generally call Kubernetes as K8S, and it's a open source container
Hmm.
orchestration tool, right? It is highly powerful,
Hmm.
very, very powerful, and that's the reason nowadays it's very, very popular in the market, and many organizations are using. Of course, there are other competitors as well, but container orchestration tool like Kubernetes is going to be the top. And why we use Kubernetes here? Automated scaling. Of course, we are looking for automated process only. Self-healing. Healing is nothing but like whenever there is a container failure, it should automatically restart or recreate on failed containers. Load balancing. This is also again a very important thing to consider. When there is a huge traffic on our application, we have to be able to manage the traffic, right? And also rolling updates. Let's say we have deployed version 1. Later on we have version 2 to deploy. In that case also, if there is any issue with the version 2, then quickly we must be able to roll back to the previous version. This is also possible. And multi-cloud. So Kubernetes can be used on-premise, or we can also use it on cloud. Anywhere you can use it, even on hybrid. So these are the important
Hmm.
pointers to note why we are using a Kubernetes here. Now this is very important to understand like Kubernetes architecture, which is going to help us to understand how actually a
Hmm.
Kubernetes work. Now as of now, we have created one EC2 instance, right? We have created one EC2 instances, and we have installed Docker on top of it, and we have created containers. Of course, one container, two container, 5, 10 containers, we can easily create and manage. But we want high availability. High availability means more than one worker node, more than one server, more than one EC2 instance. We generally call it as high availability. Let's say this is one EC2 only. We can consider it as EC2 only, like on top of EC2 we are doing this. So we call it as a worker node in case of Kubernetes terminology. So whatever the server that we are talking about, it's a worker node 1 and worker node 2. There are two machines. This is also EC2 and this is also EC2. When you want to manage more than one worker node, like let's say 2 worker nodes, 3 worker nodes, 50 worker nodes. So what we have to do, we have to combine all these worker nodes together to automatically manage, right? So when we are combining all of this, okay, so 2 worker nodes combined with a master node, we'll discuss about master node. So when we combine all of this together, we call it as a cluster. So what generally is a cluster? Cluster is nothing but it's a combination of multiple nodes. Multiple nodes are called as a cluster. Now that's the reason whenever we talk about a Kubernetes, we call it as a Kubernetes cluster. Everywhere we generally use this term. Right. So what is a cluster? Cluster is a combination of multiple nodes which are combined into a single unit for better operations. Right. Now in this cluster, it consists of one master node, and there can be any number of worker nodes. So one master, it's like a, we can say for better understanding, team leader, okay, team leader and team members. So how they are managed? So team leader is a kind of person who is going to lead and who is going to manage the entire team members. So in the same way here, Kubernetes master is a main component, main node, which is going to manage the worker nodes under it. Right. Now Kubernetes master has various components like controller, Kube API server, scheduler, and etcd. These are very, very important components in Kubernetes master node, which helps us in automating everything. So Kube API server, in the name itself, we can understand, which is going to communicate with all APIs, which is going to take care of communication. Controller, in the name itself, we can understand it's going to control the entire cluster. Scheduler, which is going to schedule the job to a worker node. Same like a team leader assigning a task to team member. Here also, master node is going to assign a task to worker node to perform and manage all the containers. And what is etcd? It's a kind of key value based database, we can say. So everything related to the cluster, information related to the cluster is saved in etcd storage. So these are the important Kubernetes master node components. Now, when we talk about worker nodes, in worker nodes, we have kubelet and kubeproxy. Kubelet is one such agent which is installed on worker node. So whatever the master communications are there, these are first instructions are given to the worker nodes kubelet. Now kubelet is a kind of like team member who is going to collect the task from team leader. Right. And kubeproxy for external users. Kubeproxy is going to serve the content. Okay, kubeproxy is one such component in worker node which will act as a networking for all these cluster or worker nodes, which is going to serve the content to them. So whenever we talk about a worker node, we come across the term called pod. What is a pod here? So pod is an important term in Kubernetes, which is going to manage one or more than one container. So this is container 1, container 2, container 3. So pod is a external layer, or we can say external boundary, which is going to manage a container inside it. Okay. Now there can be one container or more than one container. So here in this pod 2 we can see there are two containers. Here in pod 2 we can see there is only one container. Here in pod 1 you can see there are three containers. So it can be pod can have one container or more than one container, right? So we can say it's a wrapper or it's a layer to a container, right? So this is the Kubernetes architecture, and it's going to help us in managing entire Docker containers, all the Docker containers, like hundreds of Docker containers using this Kubernetes master node. So master node is going to take care of this, right? So this is how uh, Kubernetes is going to work, and this is the important architecture to be discussed. Hope this is clear, or any questions on this?
I have, I mean, but now it's okay. Like this Kubernetes, it's provided by even Azure, right?
Yeah, even in Azure we have AKS, no? Azure Kubernetes Service,
Yeah, okay, yeah,
AKS. So we
yeah,
can
got
also
it.
use Azure based service, AKS. In case of this is for Azure, and
Okay.
EKS for AWS.
Amazon,
Yes, Amazon.
AWS, right? Okay.
Yes,
And
Amazon.
here, this cluster features like cluster, which you said master and worker, it's all, I think it's the same concept on the host level also, right? We have the cluster thing there you add as a host, as a master, and then
Of course, we have.
add the client
So
to that.
let's
So
say
you can
I'm
inherit that.
installing on a virtual machine, VM. Here also
Mhm,
we'll
mhm.
have a cluster again. So this is
Yeah.
master, and we have worker
Yeah.
node 1, worker node 2, like this. So this is the base VM, and this is the entire cluster.
Mhm.
So every cluster is
See,
included
and
with
another thing,
one. Yeah, please. Yeah, go ahead.
yeah.
Please go ahead.
No, this is like another question. Like your virtual machine, easy. Let's say is it easy to instance. So AWS itself, we providing this auto scaling for that, right? So above that EC2, if you are installing the Docker system, by
Mhm.
default EC2 will be providing auto scaling, right? Like or a high availability. If it is goes down, it will be like managing that resources in another
So
server also. So
so auto scaling group. I think you're talking about ASG, auto scaling group, which is going to take care of multiple servers, EC2, EC2 server, EC2, EC2, like this. So it's going to
yeah.
manage only increase or decrease in the worker node. That's it. But Kubernetes is going to
Okay.
manage containers. We are talking about containers, not servers.
And
Okay. So we
not
are
server.
talking
Okay.
about containers. So Kubernetes is going to manage all the containers, like thousands of containers. But auto scaling group is
Mm-hmm.
going to manage EC2 server, like we are calling it as node, right? Worker node. All
Node,
these are
yeah,
worker nodes.
yeah.
So these nodes are managed by auto
Mm-hmm.
scaling group. Of course, you are correct. And containers are managed by Kubernetes.
Okay.
So in a Kubernetes cluster, which includes multiple nodes and also multiple pods, and inside pod we have containers, right? This is a
Okay.
worker node,
Can
we
you
can say.
explain me any real-time usage of this Kubernetes in organization, like where they are using this Kubernetes?
Everywhere we are using. Yeah, let me show you this.
Okay.
Yeah, this is the question, right? See, we are
Uh-huh.
talking about Netflix, right? We know Amazon Prime.
Mm-hmm.
We have Geo Hotstar.
Yeah.
So recently there was a news that Geo Hotstar is able to handle 50 CR, 50 crore of traffic. Have you heard of this
Okay.
news? Geo Hotstar, like
No.
whenever we talk
Mm-hmm.
about live match, live cricket match.
Mm-hmm.
So just imagine how many people will watch cricket match, live match. Just imagine the count.
Yeah. Huge.
Huge numbers,
Yeah.
right? This is possible with Docker and
Mm-hmm.
Kubernetes. Okay.
Okay.
This is possible with Kubernetes. And also in addition, we also
Mm.
have, we'll install Docker inside this. That's a different thing. But of course, Kubernetes is managing all of this. It scales like anything. Like it can provide the like a
Okay.
services to any number of traffic count. Right. So you can see the real world use cases that you mentioned. So CI/CD pipelines, as a DevOps engineer, we will definitely integrate Kubernetes here. Microservice based architectures, we can run,
Mm-hmm.
manage multiple servers efficiently, big data, AI, hybrid cloud, and all of this. Okay. So just now, whatever the example that I gave, like Netflix, one movie can be watched by
Mm-hmm.
millions of people at a time. Recently released movie.
Yeah.
Amazon Prime, one
Yeah. Yeah.
movie, one movie equal to
Yeah.
millions of traffic at a time. Same like cricket match,
Yeah. Yeah.
live news.
Mm-hmm.
Like this is possible with Docker and Kubernetes. Docker and Kubernetes are very powerful tools,
Okay.
right? Now,
Okay.
yeah, as we are talking about this Kubernetes architecture in control plane, as we discussed, like there is a controller, there is a kube API, scheduler, and etcd. These all are the components of control plane, and these all are the components of
Okay.
worker nodes. Okay, and
Worker.
yeah, so here we can see as a user. Okay, let's say you are a DevOps engineer. Now we generally deal with Kubernetes clusters.
Mm-hmm.
Okay, now we will
Yeah.
write files. We will write some scripts, YAML files, and we will provide that YAML file. We will execute that
Yeah.
YAML file. Let's say deployment. Let's say
Hmm.
you want to create a cluster as well. Of course, let's say you want to create a replica set. You want to create a service, SVC. So
Hmm.
there are many terms in Kubernetes. Okay, so many types of services are also available. Like we can create a node port, we can create a cluster IP, we can create a elastic load balancer, anything. So we will write everything in a YAML format and we will execute that. So Kube API server is going to take that input and it's going to store that input in the etcd and discuss, like it's going to communicate with the scheduler, control manager, and all of this. So further, it's going to work with multiple worker nodes. All these worker nodes can be EC2 instances, servers, right? So like this,
Hmm.
it's going to create multiple pods. Like this is pod one, pod two, pod one, pod two, pod one, pod two, and all of this. So there can be multiple containers. Okay. Like this, we generally create. So thousands of containers, same like the example that I gave, Geo Hotstar live match. This is
Yeah.
possible with this kind of Kubernetes only, right? And important terminology like we call pod. Pod is nothing but it's a protective layer to a container which is going to manage the container. Okay, and replica set where you want to create a specified number of replicas. Like always, you want to maintain 50 replicas, 50 number of pods. And deployment, we can even create a deployment which is going to take care of a rolling updates and scaling and all of this. And we also have services like node port, cluster IP, and also we have elastic load balancer and all of this, which are going to help us in communication with pods, outside communication, ingress controller, which is going to take external traffic, which is going to monitor external traffic and all of this. So these all are important terms in Kubernetes. So what is the difference between Kubernetes and Docker Swarm? And in Docker, we also have a platform called Docker Swarm, which can be used to orchestrate. This is also orchestration platform. This is also an orchestration platform only, but it has a manual process, limited, and needs external tools, and self-healing is not there, and it's used for a simpler, like simpler basic kind of networking and all. And also production readiness, it's not, we can say it's not robust, or we can say it's not more efficient in production workloads. So we generally go with the Kubernetes in place of Docker Swarm, right?
Okay.
Kubernetes has very good features, advanced We can use it in production, automatic, built-in services. Of course, we can have a self-healing, more complex. We can have more complex network which can handle millions of traffic requests. Enterprise grade. So mostly for enterprise uh, kind of applications, we generally go with Kubernetes, right? Now to set up this Kubernetes, just now we have seen for Docker, no, like we have created one virtual machine, and on top of virtual machine, we have installed Docker and we have created a containers. To set up this Kubernetes also, we have different ways. We can go with a mini kube, which is a local setup. So with a single node. Okay. So Kubernetes means just now we have seen in this architecture, you can see there is one master and multiple worker nodes, right? So, but to make it very, very simpler for us to use locally and practice and all of this, we can go with a single node kind of Kubernetes cluster. We can't say it's a cluster, but single node. So if you want to work with Kubernetes on different cloud platforms, as we discussed in AWS, we have EKS, and in Google, we have GKE, and in Azure, we have AKS, Azure Kubernetes Service, and Google Kubernetes Engine, like this. So in AWS, you can create a EKS cluster. You can create a GKE cluster in Google. You can create a AKS in Azure. So we have many commands to work with, right? So if you want to prefer a cloud based, then you can go with a cloud based like EKS, GKE, AKS, right? If you want to do a practice, or you want to work in a local environment within a local machine or one particular server, then in that case you can go with a single worker node. But generally, I recommend you not to go with a single node. But if you want to practice, always go with a like COPS kind of cluster. COPS, or we have Cube, ADM. So you can go with this kind of clusters. So this is going to give you like a real-time environment where you can work with. Okay. So hope this is clear to you, Rohini. Any questions?
Yes. No, like I have, the setup, everything. This Docker thing is like, is it only have a CLI access, or do we have a GUI as well,
We even have
or a Windows server?
Windows desktop is there, no? Like Docker desktop. We can also download
Uh-huh.
Docker desktop.
Okay.
We have many
And we
options.
can follow the same, like create a Docker
Yes.
file or something.
Docker
Okay.
Docker installation. You can see here install Docker engine. Now we have many platforms. If we talk about
Uh-huh.
Linux based like CentOS,
Okay.
Debian, Fedora, and all of these, RHEL,
Linux
Ubuntu,
based.
and all of this. And if you want to go with a
Mm.
different like a Windows also, you can go with a Windows and all of this. So for Windows, we have Docker desktop and all. So you can use that one as well.
But mostly Linux, everyone will be using, right?
Everywhere Linux only. So it's a very good practice to go ahead with Linux only instead of Docker desktop and all of this.
Linux.
So those are just
Mhm.
those are going to help us in like quickly using that, like quickly navigating using our cursor and all of this. But I
So
recommend to
is it
go with
a subscription based service, or for
Docker
the
is a free
organization?
platform, no? Docker is free.
Okay. Open source. Yeah, yeah, yeah.
Open source, no? Docker is open source and free to use.
Mhm.
So we can
Mhm.
use it, no problem. So this is what you are talking about, like Docker desktop. You can even install
Yeah.
Docker desktop on your machines. So we have Mac, Windows, and
Mhm.
even on Linux also we can go with this. And if you are using a Windows, then you can
Mhm.
simply go ahead with this Docker desktop on Windows. You can follow this ARM architecture or
Okay. Okay.
x86, and you can click on this. This is going to download, and we can install it and we can work with this.
Mhm. Oh,
Right.
like if I want to do a lab setup or something in my personal laptop, how I can configure this thing? Like
So,
if it is required any Docker.
so you want to work with Docker? Hmm.
Yeah, like if I want to, gain experience in this thing,
Okay.
obviously EKS service or will be used, right? chargeable, right? Like from Amazon.
Yes, those are chargeable. So generally, if you are ready to pay the bill, then we can go ahead with that. Or else, if you want to practice it, I'm sharing the link here how to install Docker onto your Ubuntu machine.
Okay.
Or else you can even
Okay.
go with Docker desktop as well. So this is Docker desktop. I'm
Okay.
sharing the links for you.
Mhm.
Okay.
Okay.
And apart from that, you want to work with, you want to practice, right?
Yeah.
Docker labs, or we can say. So we generally have labs for us. So let me search for you.
Mm-hmm.
So these are from official docker.com only, official Docker websites only. So we
Okay.
have many
Okay.
labs to perform. We can even easily learn. So Docker labs here.
Mm-hmm.
So there are many platforms. You can just refer this. There are many guides available.
Okay.
You can use it for performing labs. Okay, this is one such Docker labs GitHub guide. This is for beginners, developer related tools and all of this. Okay, so here you can see Docker for beginners, Docker Swarm and all of this you can see. Okay. We'll go with other and see Docker practice labs. So we have some labs, but of course those labs are like in
Mm-hmm.
private repositories, not in public.
Okay.
So even for Docker, we have many, we can say labs, official labs here. So here you can see this is the running a first container. Lab 1 running your first container, and lab 2 you can see adding value to the Docker using Docker images. You can create Docker image, you can push the Docker image. Okay, all of this. So this is also an important guide which I
Okay.
can share it with you. These are from official Docker only.
Oh.
Okay, so how to install
Are
Docker? How
you
can you
pasting
version?
on the chat here or the link?
I think chat access is not there for you, right? I'm sorry. I think you
No,
don't
right?
have chat
That's what
access.
I'm just trying to,
Okay.
I don't have. I was just
So
trying
yeah,
to refresh it.
whatever I have
So I.
shown here, I think you can just search light
Mm.
chat
Yeah, yeah,
access.
yeah. I will. I will.
So you can
Mm.
even search for this, like whatever I'm showing here. So Docker installation on Ubuntu, Docker installation on Windows, and also
Yeah.
like you can use labs, Docker labs. You can simply search for Docker labs here. So where you can go with all of this.
Okay.
Okay. So hope this
Okay.
is helpful to you, right? And
Yes.
okay. So yeah, Kubernetes cluster, we have many options here. Okay, to show like Minikube is there, and
Uh-huh.
we can even go with this. We also have, if you want to take this screenshot, you can take this screenshot, like install setting up a Kubernetes
Okay.
on a single worker node local setup. You can just install this, going through the Minikube and installing
Yeah.
kubectl. So like this, we can do it. We have a Docker hand,
Mm.
like Kubernetes hands-on also, like where we can do it using a kops cluster and also kube ADM. So these are the other options which we can go ahead and create the kops cluster. So this kops cluster is going to create one master plus two worker nodes. Same like the cluster that we have seen now. Okay, this kind of cluster we can create with the kops and kube ADM. Okay, so
Mhm.
okay. So other than the Docker and Kubernetes, any other questions, like do you have any follow-up questions, or let's discuss about certifications and all?
A certificate. Yeah. Like. So We have different kind of certifications, right?
Yeah. So if you are a DevOps engineer and who wants to get certified, then you can go with the AWS based certification like AWS DevOps Engineer Professional, Azure. We have Azure DevOps Engineer, and also for Google, we have Google Professional Certification. And especially if I talk about the Kubernetes certification, we can see we have CKA, Certified Kubernetes Administrator, Certified
Mhm.
Kubernetes Application Developer, and also security related certification. So nowadays, holding a Kubernetes certifications will give us very good recognition because most of the production workloads
Okay.
work on Kubernetes only. It's very good to write the certification and get recognized. So whenever we add these certifications in
Yeah.
our resume, definitely these are going to help us. And apart from that, like
Mhm.
as a DevOps engineer, it's very good to know about HashiCorp Terraform, where we actually use it for
Mhm.
automating the creation of infrastructure. Hope you are aware of this because you are an
Mm.
infrastructure
Yeah, yeah.
engineer, right? DevSecOps, nowadays we are also
Yes, yes.
integrating security along with the DevOps, and we can even have a,
Mhm.
security related certifications and all. So these are the important tips for resume
Okay.
and job search. If you want to take a screenshot, you can take a screenshot of this. These are
Yeah.
also going to help you.
What will be the cost involved here for the certification?
For yeah, so every platform like
Minimum.
DevOps, yeah. So for professional level certification, it's 300 USD. You can simply go to Google and AWS
Okay.
DevOps Engineer certifications. So if we click on this, it's going to take us through the certification here. We have many certifications. So out of that, this is one of the certification, professional level certification, which is going to charge you 300 USD for
Okay.
professional level certifications. And if you want to write associate, they can charge 150 USD. And if it is a like practitioner level,
Mhm.
fundamental level, it's going to be 100 USD. Okay.
Okay.
And
Okay. Thank you.
so if you want to know more about, so like this, we have many certifications, and this is the total list of certifications from AWS. So we have foundational level two certifications and associate level, these many five certifications. Professional, which includes DevOps engineer and solutions architect professional. And in specialty, we
Mhm.
have this. So if you want to learn DevOps and if you want to focus on AWS based DevOps, just now we have seen this, no, like it's going to charge 300 USD. And before this, for DevOps engineer, we can either go with a developer associate or SysOps or solutions architect. So with this, we can have once we clear developer, then we can go for DevOps engineer. So this is a general flow. If you are writing associate certification, then you can see it's going to charge you 150 USD.
20.
150, yes. So time is 130 minutes. And all this we get through Google, right? All the certifications we can easily search.
No.
Okay. Right. We also have
Okay.
a job support program here where you'll be getting a complete job support once the
Okay.
training is done. So this is the general flow. You will be
Any
having a,
interview will be scheduled
of course we have mock interviews. Okay. So where
mm,
technical trainers and experienced professionals are going to take your mock interviews, and there like once you are like what will happen is like you will be in training. After the training, you will enter into the live project for 1 month. So as you are doing your
mhm,
live project in the like our
mhm,
backend teams are going to work in on your resumes, like CV analysis and searching for the
mhm,
job. Once your profile is shortlisted, we will go through the job description there, and based on the
mhm,
job description, we will prepare you for the interviews. Like this is the job description, and they are looking for this kind of skills and certification. So based on that, we will
mhm.
suggest you where to focus more to crack that particular job. So as a part of that, you will be
Okay.
having mock interviews, right? So in that mock interviews,
Mhm,
you can analyze yourself, like I'm at which level, and which are the areas to focus and improve and all of this. So these mock interviews are going to help you in cracking that interviews. Yes. We also have CV analysis, where we will be preparing your CVs based on uh, like latest ATS tracking based keywords and
Okay.
important description, job description. Based on that, we'll be going through that. All right.
Okay.
Any other questions?
Okay. No, at the moment I'm good. Like,
Right. Hope you got insights and session is insightful for you.
yeah, definitely. I didn't had much experience on this containers and Kubernetes, but which
Okay.
is like very informative session.
Right. Right. Thank you so much, Rohini. Thank you for joining the
And like
webinar.
one more question.
Yeah. Yeah. Please go ahead.
See,
Please go ahead.
in this now in like how the job market is on DevOps. Like, are
Yeah.
we
Uh,
having more opportunities there?
yes. I'll show it here. So DevOps jobs in UK. You can simply search in the Google. Okay. You can simply search in the Google like this. You
Mm-hmm.
simply see here 100 plus more jobs here. You can see like job notifications like 2 days ago, 4 days ago, 20 days ago, 3 days ago, 3 days
Yeah,
ago.
yeah.
And you can see here like 3 days ago, 13 days, one
Because
day.
I am in graduate visa now. Like I won't be
Okay.
having I'll be having visa till 2020. The main issue, like whenever I'm applying, they are saying about the visa problem. So that's what I'm concerned whether they will be
Okay.
taking
So yeah.
graduate person or after.
So like if you already graduated, right? Post graduation. MS is done.
Yeah, just September graduated and I took the graduate visa November, like on November. So it will be there till November 2026, almost an year
Okay.
plus, like two year. So that's what
Okay.
like I have attended 2-3 interviews now. Mainly they are in the initial screening call itself. They are saying about the visa. So that's what if we are doing this DevOps and
So
like
you're talking
how
about time, right?
are we supporting that's what.
Quickly,
Yeah.
quickly getting a job, right?
Mm,
You're talking about a quickly getting a
yeah.
job and say like you can simply join a job and you can change your visa type, right? So of course you can see here, as I
Mhm,
mentioned,
mhm.
number of job openings are there like 2 days, 2 days, 5 days, 3 days, 4 days. You can see here simply
Okay.
like 2 days and all of this. So current job market is like booming. Okay. So already many organizations are
Mhm.
already implementing DevOps and they are in need of number of DevOps engineers, right? So you can simply check in the Google
Engineer,
instead
yeah,
of
yeah, yeah.
my inputs and all. So everything is like in front of you only like 4 days, 17 days, 4 days. Again,
Correct,
many opportunities are there. So we can easily apply and we can
Mhm.
crack the job. No worries at all.
Okay. So once we are selected in the interview, like the team IT Talent Hub will be providing a mock interview or something, right?
Of course, of course. Of course. So once
Yeah,
your
yeah.
profile is
Got it, got it.
shortlisted, you will be having all of this
Mhm.
like based on the job description. We will take the job description and we will analyze it. What actually they are looking for, what skills they are looking for.
Okay,
So based on that, we will brush up the
okay,
skills that are required, and we will just take conduct a mock interviews kind of sessions and
okay,
all.
okay.
Those are going
Got
to
it.
really help you. Yeah.
Okay, okay. Yeah,
Any other questions, Sohini?
yeah. This is good. Yeah.
Okay. Okay. So, yeah, that's it from my end for today's webinar. Hope this session is helpful to you and
Mhm.
hope
Yes.
you will be in touch with us. Yeah.
Sure, sure.
Thank you. Thank you. Thank you so much for
Definitely.
joining.
Thank you. Thank you for your
Thank you.
time.
Yeah.